All right, welcome to the Explainer. Today, we are diving into something that's basically the secret engine of the entire digital world: repetition. It's the core idea that lets computers do these massive, tireless jobs, and we're going to break down exactly how it all works. You know that feeling, right? That just mind-numbing sensation of doing the same task over and over and over again? Well, in the world of programming, that feeling isn't just tedious, it's a trap. Trying to write code manually, one repetitive line after another, is just slow, it's begging for errors, and it is the absolute enemy of getting things done efficiently. But here's the thing, and this is the really cool part. Repetition is also a superpower. It's how we achieve huge, complex goals. I mean, think about it. A scientist has to run hundreds of trials to get a breakthrough. A 3D printer builds an incredible object, one precise layer at a time. Repetition, when you can control it, is literally the foundation of creation. Okay, so let's get specific. Why is just copying and pasting the same line of code again and again considered such a major no-no in programming?
Let's imagine a super simple task. We want to print the multiplication table for the number 9. So the most obvious way to do it is to just write it out, right? Line by line, one line of code for each calculation. Seems simple enough. What could possibly go wrong?
Well, this approach falls apart, and it falls apart fast. I mean, it's fine for a few lines, but what if you needed 100 multiples, or 1,000? All of a sudden, you're staring at this massive, unreadable wall of code. And don't even get me started on making changes. If you find one little typo, you might have to fix it in hundreds of different places. It's a total nightmare. Thankfully, programmers came up with a way more elegant solution for this. It's a really powerful tool called a loop. And this is the magic right here. This is what's called a for loop. Just look at that. Instead of typing out every single calculation, we write a single instruction, and we just tell the computer how many times to repeat it. That giant wall of code we just saw, it's now just 3 clean, compact lines. Now that's the power of automation. So how does this thing actually work? Well, every for loop has 3 key parts. First up, the initialization. That's where we set up a little counter variable and give it a starting point, usually 0. Second, you've got the condition. This is the rule the loop checks every single time. As long as it's true, the loop keeps running. The second it becomes false, it stops. And finally, there's the increment, which just updates the counter after each pass, usually by adding 1. But it doesn't just stop there. Loops are way more than just simple counters. There are these incredibly flexible tools that you can customize to repeat in all sorts of clever ways. For a perfect example, what about counting down? Easy. We just kind of flip the script on those 3 core parts. We can start our counter high, say at 10. We change the condition to run as long as the counter is greater than 0. And then, instead of adding 1, we just subtract 1 each time. We can also change the step size. What if you don't want to count by 1? What if you only want, say, the even numbers? It's simple. You just tell the increment part to add 2 to the counter on each pass instead of just 1. So by just tweaking these little parameters, you get this really precise control over exactly how the repetition happens. Okay, now this is where things get really powerful. What happens when you put a loop inside of another loop? Well, this technique is the key to working in 2 dimensions, like building a grid with rows and columns. This, my friends, is where we used a nested loop. The idea is actually pretty simple. You have an outer loop that's in charge of the rows, and for each of those rows, an inner loop runs to build out all the columns. It's perfect for creating tables, grids, or, a field of digital snowmen. So here's the key to really getting how this works. For every single time the outer loop runs, the inner loop runs to completion. So think of it this way. The outer loop says, okay, let's build row 1. The inner loop then kicks in and does its entire job, placing a snowman in every single column of that one row. And only after the inner loop is totally finished with that first row does the outer loop take its next step and move on to row 2. And this whole process just repeats, row by row, until that outer loop has finished its run, and boom, just like that, our entire grid of snowmen is complete. And this brings us full circle, right back to our original problem. With a nested loop, we can generate the multiplication tables not just for the number 9, but for every number from 1 through 10, all with just a few lines of unbelievably efficient code. And this setup is just so efficient. The inner loop runs 10 times, but the outer loop makes it do that whole dance 10 times over. So what's the result? Our little print line function gets called 100 times, doing 100 calculations, all managed by this tiny, compact structure. Now, the for loop is like the trusty Swiss Army knife of repetition, for sure. But it's not the only tool in the toolbox. The core concept of repetition is totally universal in coding, and it pops up in a few other important ways. You see stuff like pseudocode, for instance, which is all about showing the pure logic of what you want to do without getting bogged down in the specific rules of, say, JavaScript or Python. This example here clearly shows the logic for a countdown. You set a counter, you repeat a set of instructions 10 times, and you subtract from the counter each time. The idea is the same no matter what language you're speaking. And then there's this other kind of mind-bendingly elegant approach called recursion. So instead of a loop telling the computer what to do, recursion is when a function calls itself over and over again, breaking a big problem down into smaller and smaller identical pieces until it's finally solved. So you might be asking, okay, which one is better? And the answer is, well, it depends on the job. Standard loops, which we call iteration, are usually faster and use less memory. They're the go-to for most day-to-day tasks. But for certain really complex problems, like navigating a huge family tree with all its branches, recursion can be a much more intuitive and, frankly, beautiful solution. They're just two powerful tools for the same fundamental goal, repetition. Okay, so after going through all of this, what's the big takeaway? Why are loops so absolutely essential to programming? It really all boils down to this. Loops are the engine of automation. I mean, the world around us is just filled with patterns and cycles. So to build programs that can automate and simulate that world, we have to have a way to manage repetition. And that's what loops do. They let just a handful of code perform thousands or even millions of operations. So I want to leave you with a final thought to take with you. Loops aren't just a programming tool, they're really a mindset. They're about finding patterns and creating elegant, efficient solutions. So look at your own daily routine. What's one repetitive task you do every day that could, in theory, be automated by a loop?